For the first time in over half a century, we are going to see the far side of the moon through human eyes. The crew of Artemis 2 is about to travel beyond where no one has been for a very long time, to a place of absolute silence and mystery. But what they are going to look for in those minutes of total isolation, while the moon blocks all signals from Earth, is not just an ancient landscape full of craters. It is an opportunity to see, unfiltered, a world that could change everything we know about our cosmic neighbor. What secrets do they hope to discover that already have us on the edge of our seats? The answer will not only shape the future of lunar exploration, but will also remind us how little we really know about the satellite that has always been with us. To understand how big the Artemis 2 mission is, we have to look back to a time of glory and to a very long pause of 50 years. The Apollo era took us to the moon, left footprints in its dust, and changed our view of the universe forever. But after Eugene Cernan, the commander of Apollo 17, took the last human step on the moon in 1972, crewed deep space exploration was put on hold. Priorities shifted, and attention turned to low Earth orbit with the space shuttles and the International Space Station. The moon, our shining nighttime companion, once again became a distant destination, visited only by robots. Artemis II marks the end of that wait. It bridges the Apollo legacy and a new era in which humans will once again be present in the cosmos. This mission is the first crewed flight of the Artemis program, and its objective is clear: to confirm that the Orion spacecraft and its rocket, the SLS, are safe and ready to take us to the depths of space. No, they won't be landing. Think of it as a dress rehearsal with fireworks, a trial by fire for the missions that will actually return to the lunar surface. On board Orion is a crew already making history. NASA astronauts Reid Wiseman, Victor Glover, and Christina Koch, along with Canadian Space Agency astronaut Jeremy Hansen. Together, they will not only test the spacecraft's systems but also become the first humans in more than 50 years to see the moon up close and contemplate with their own eyes that side it never shows us. The mission is a 10-day celestial choreography. After liftoff, Orion will orbit Earth twice to ensure everything is working properly. Then, with a boost from its engines, it will launch into a lunar-free return trajectory. What does that mean? It will fly toward the moon, use its gravity to circle it, and return to Earth like a cosmic slingshot. During this journey, they will break the distance record from Earth set by the Apollo 13 crew, going farther than any other human being. The most intense and symbolic moment of the mission will come when Orion slips behind the moon. For about 40 or 50 minutes, the moon itself will block all radio and laser signals connecting the crew to Houston. It will be total silence, an inevitable and perfectly planned communications blackout. For the 4 astronauts, it will be an experience of brutal isolation, a solitude that only 24 people before them knew on the Apollo missions. Without the constant stream of data and the reassuring voice of mission control, they will depend only on their training, the spacecraft, and themselves. Astronaut Victor Glover asked that, during that moment, we here on Earth take a moment to reflect and send them positive energy as they traverse that void. While on Earth, the engineers wait anxiously for the signal to return, the crew will have a monumental task ahead. Far from being a break, those minutes will be a unique opportunity for exploration. With the cabin windows pointed at the lunar surface, the astronauts will become geologists, astronomers, and photographers, observing a landscape we've only ever seen through robotic eyes. This radio silence isn't a mistake, it's a law of physics. It's the ultimate proof that Artemis is truly venturing into deep space and demonstrating that it can operate independently once the umbilical cord to Earth is severed. When the commander says, "See you on the other side," it won't be a casual remark. It will be the entrance into a territory where human experience takes over. So, what will they see on that far side? Thanks to decades of robotic missions, such as NASA's Lunar Reconnaissance Orbiter and China's Chang'e probes, we have a pretty good idea of the landscape that awaits them. Although, let's be honest, no photo taken by a robot can compare to what a trained human eye can capture. The far side of the moon is a completely different world from the one we see at night. While the near side is covered in dark plains of lava, the famous seas, the far side has almost none. Instead, it is a much older and more rugged terrain, riddled with craters. The lunar crust is much thicker on this side, which prevented magma from the interior from erupting to fill the impacts. thus preserving a geological record spanning billions of years. One of the crew's major objectives will be to observe the Oriental Basin. It is a monstrous impact crater, nearly 1,000 kilometers across, so large that it straddles both the near and far sides. Although probes have photographed it, no human has ever seen it in its entirety. The crew's direct view will offer a three-dimensional perspective that flat photographs cannot provide, helping us understand the violence of the impacts that formed our solar system. They will also be on the lookout for anything that moves. They will look for flashes of light from meteorites colliding with the surface, something easier to see against the dark terrain and without Earth's light. They will also observe the levitation of dust particles on the lunar horizon, a strange electrostatic phenomenon that we still don't fully understand. Scientists are also hoping the crew will provide clues as to why one side of the moon is so different from the other. Samples from the Chinese Chang'e 6 mission already revealed very different rocks and water on the far side. Although Artemis II won't collect anything, its observations of the surface's colors and textures could be key to validating models of how the moon formed and evolved. In short, no, they won't find lost civilizations, but they will reveal the true face of an ancient and fascinating world. It's a good question. If we've already sent robots, why risk people? The answer lies in the irreplaceable power of the human eye and brain. A robot follows orders. It captures the data it's given, and that's it. In contrast, an astronaut sees the whole picture. They might notice something unexpected, an anomaly, a color, or a texture that a sensor wasn't programmed to detect. When Christina Koch or Victor Glover look out the window, they won't just see craters. They'll see geological patterns, layers of rock exposed by an impact, color variations that could indicate distinct minerals. Their training allows them to interpret the landscape in real time and identify interesting features that weren't on the flight plan. Christina Koch, for example, might describe a recent crater as a lampshade with tiny holes, giving us insight that raw data could never provide. The images they capture won't just be pretty pictures. They will be crucial data for planning future Artemis missions. Seeing the terrain's roughness or the slope of craters is vital for choosing safe and interesting landing sites for Artemis III. The visual information they gather from permanently shadowed areas near the poles will help scientists determine where water ice might be found, a key resource for future lunar bases. And of course, there's the human factor, which is priceless. The experience of seeing Earth appear and disappear behind the edge of the moon, a blue and fragile planet amidst the darkness, is something that inspires and unites us all. The stories and photos brought back by the 4 astronauts will have the power to fascinate a new generation, just as the Apollo images did. Artemis II doesn't just test technology, it reaffirms why human exploration is worthwhile, because of our need to go, see, and understand for ourselves. The Artemis II journey across the far side of the moon is much more than a technical achievement. It's a symbolic moment that closes a long chapter of waiting and opens a completely new era. Every piece of data, every image, and every observation made in those 40 minutes of silence will be the foundation of our future in space. This mission paves the way for Artemis III, which will finally return us to the lunar surface, including the first woman. What they learn on Artemis II will tell us where to land, what tools to take, and what to look for. And beyond that, this mission is a giant leap toward a sustainable presence on the moon, with the future Gateway station serving as a lunar orbiting base camp. In the long term, the moon is just the springboard, the training ground for the technologies that will one day take us on the most incredible journey of all, the human exploration of Mars. The 10-day odyssey of Reed, Victor, Christina, and Jeremy will remind us that exploring space is a profoundly human endeavor, driven by curiosity, courage, and an unstoppable desire to see what lies beyond. We don't know what wonders await them in the silence of the far side, but one thing is for sure. When the Orion signal returns, we'll have a new story to tell about our eternal celestial companion. Exploration is just getting started. Artemis II is only the first crude step toward returning to the moon and staying. Want to follow what's next? Like the Artemis III landing and the construction of the first lunar base? Subscribe and turn on notifications so you don't miss anything from this new era of discovery. And now I ask you, what mystery do you think the moon still holds? Let us know in the comments.